For the third question, we need to prove the following identities. And for part A, this is the identity that we need to prove. Note that in the right hand side, we have two terms, cotangent A and tan to A. So we're gonna start with right hand side first. Cotangent A is 1 over tan A, and tan to A is 2 tan A divided by 1 minus tan squared A. Final answer should only have one term only. So here we have two terms. So I'm going to combine these two terms to get one term only. So note that this is actually 2 tan squared A. And we will get this. Now let's compare with the final answer that we should have, which is this one. Cotangent A is 1 over tan A, and secant to A is 1 over cos 2A. So try to rearrange our answer in order to get in that form. Note that this is 1 times 1 plus tan squared A. So I'm going to separate it to become 1 over tan A times with this fraction. So that's how you get 1 over tan A times 1 plus tan squared A over 1 minus tan squared A. So if we compare with the final answer, we have already found 1 over tan A. So now we just need to change this fraction to become 1 over cos 2A. So let's change everything here to become in terms of sine and cos. So our final answer should have 1 over cos 2A. And we already know that this is actually equal to 1. And what about cos squared A minus sin squared A? Note that cos 2A is actually cos squared A minus sin squared A. So this is actually cos 2A. And we already know that this is cotangent A and this is secant 2A. So just be careful with the angle. Here is A, that's why this is cotangent A. But here the angle is 2A. That's why this is secant 2A, which is equal to the left hand side. So that's how you prove that the identity in part A is correct. This is the identity that we need to prove for part B. So which one do we start with? Is it left hand side or right hand side? If you see any identity that have sine, cos, tan, and then it has 3A, 4A, 5A, 6A, 7A, etc., which means that it is bigger than 2. So this means that we're going to apply the double angle formula and the compound angle formula. And hence, we're going to start with the left hand side first. And note that 3A is actually 2A plus A. So you can use A plus 2A as well. So in this case, I'm going to use 2A plus A. Using the compound angle, we know that sine A plus B is sine A cos B plus cos A sine B. And hence, we will get sine 2A cos A plus cos 2A sine A. So this is the final answer that we need. Note that in the right hand side here, the angle that we have is only A. But now in our answer, we have the angle 2A and A. So this means that you need to do something to sine 2A and cos 2A. So we're gonna use the double angle formula here. Now what about cos 2A? So which one do we use to substitute for cos 2A? If you look at the final answer here, it has only angle A and the trigo sine only in the right hand side. So we're going to choose the one with the sine only, which is this one. So cos 2A is 1 minus 2 sine squared A. Final answer should only have sine only. So we need to do something to cos squared A. Cos squared A is 1 minus sine squared A. And by comparison, we can see that our answer is the same as the right hand side. So that's how you prove this identity for part B.